Now, there is a slight difference between energy audit and this, energy system optimization. The difference is that for energy audit, you have phases. You may not have to implement. You can just come and do the assessment. Am I communicating? But for energy system optimization, you start with assessing. You give them how best it will be, and you follow them up to implementation. Am I communicating? So then we have energy system energy storage optimization. This is what I was talking about the other time, and I gave an example of storing heat inside ice. It doesn't look like it makes sense, but it is. Now, if let's say your ice, you take your ice to like minus 10 degrees C, for example. You pump it extracts heat into itself. The temperature increases to like minus 1 degree C. And through another process, you extract that heat back to make it cold, back to minus 10. Have you not gained your heat energy back? Am I communicating? This thing I'm talking about is not just what I'm talking about from my head. It's a process that is in operation in the world. Presently, today, America is investing strongly into that system. So now we have energy storage. Okay, should we use battery system? Should we use thermal storage? You store heat energy and then you later use it. Just like, solar PV system, how it works. There is no light, you store inside battery so that when there is no light, the battery gives what it has. Then you have light when there is no light, right? So, but on the other thermal, you may also have some heat energy that you are wasting to the environment. You capture them, save them, and then use them to produce electricity or energy later when you need them. Does that make sense? Next. My time is fast spent. So we talk about energy system, energy management system. So energy management system on its own, it's very broad. It's a bit different from energy system optimization in the sense that it has a step-by-step approach. How you plan, how you do, how you check, how you act. And the process is continuous. It's a cycle. It's not just a straight line. Say, I planned yesterday, I will not plan again tomorrow. It's a lie. Because when you see some other things, you pick some insight and you go again and plan again. So it's a cycle. So of course, the standards also will guide you. Then we have a tool that we introduce to you in this training. The tool is to help you with energy system management. It's an Excel tool. It's UNIDO tools. I will introduce it in the next slide. Next slide, please. So this is a tool. This is how it looks like. So it's energy system, energy management system implementation tool. So it has the place for the plan. It has the place for the do, where you do the assessment. Am I on track? But I want to say this at this time. You see, it is like when you go to the ocean and you see big, massive water and you are discouraged. Please don't be discouraged when you see it. It only looks big. One step, you will get it. The next step, you are getting it more. Are you getting me now? That's the approach to it. So we have different tabs. You see now we are already having like different tabs. It doesn't stop there, it continues. But when we are exposed to it, we get used to it more. So this is how it is. It has different phases. Next stage. So we have men as in experts with decades of years of experience. They came up with this to help. So it's a safe tool. It has been tested. It has been used in different countries, and it's working. And even we use it in Nigeria also for energy system when we want to certify, when they want to do the certification of ISO 50001 certification. It's part of the tool I use. Okay, next. So these are the components of the tools. We have You know, the planning, we have the doing, we have the check and act. But, you know, this is like the overall component, that component of ENMS tools. We have the pestle and SWOT analysis, interested party, legal. It encompasses everything. How legals will affect your energy consumption. How the top management will affect if they comply or not. How the environmental and the risks around will affect. So it's a very comprehensive tool. I want to tell you that the more you get exposed to it, the more you get familiar with it, the easier it becomes. So then we have the planning stage. That's when we have the energy planning process. We have the process overview. We have the energy types. You know, that's where you want to state all the energies that you use. You have data. When you extract all the data, you input all the data. The trends. Trend is very important. When you get the trend, for example, you get to a facility. Let's say you have their data. You see the Excel sheet, or you see whatever. You have the line diagram. Then you notice that at the time they are not supposed to be, the trend is showing that they are usually all through the year. You want to ask questions, right? Like the time is 9 to 5. So why do we have energy consumption 2 a.m.? You understand? Maybe there is an equipment that turns itself up. This will help in the planning. So you will be able to identify them. Then you have SCUs list, you have the motors, you have the heaters. Though they are usually the meaning of SCUs, significant energy uses. In facilities, you want to know which ones are more significant. So let's quickly do a simple test. So if we go to an average house, what should be the significant energy uses there? Average house. Huh? Refrigerators. ACs and refrigerators. Great. Water heaters. Great. Is that all? Iron. Wonderful. Electric cooker. Yes. Water pumps. Oh, great. Fantastic. So I'm sure now that we know. But can bulb be part of the SCUs? Huh? Like, yes. Can bulb be significant? You mean 10-watt bulb can be significant? I want to understand what we are saying. Security bulbs. Please, I would like us to talk so that we will all learn. I also want to learn from you. Who is starting first? Huh? But I heard people talking now. All right. All right. Maybe. Okay, please. Yes.
Okay, for the bulbs we use at home, if you conglomerate, if I'm to use that word, the amount of energy they take, in a day, it can even be more than that an iron would take from one person, especially when you have children in the house. So if you have energy bulb like 5 and 6 and they're consuming 10, that's 50 already. Then the amount of hours that they would stay, than that person iron that you just do once.
Okay, we want to do like, do you agree by the notion? Say nay.
You better say yes. Say yes, right?
How many of us agreed with what you have said? That if you just look the bulb now, we can't all this bulb now. It's possible all this.
Once.
How we use it.
I'm a man. It's just once.
Let me just say something.
Okay.
And every one of us here can do that when he goes back to his home. For every pressing iron, if you look at it, it has a regulator. Mm-hmm. And on the regulator is marked wool, cotton, nylon, So for each of those materials, there is a particular settings that you can use that pressing iron efficiently without any problem. That is using the energy efficiency. You understand? But in a situation whereby, if you get this ordinary megad who used to do the pressing, You see, you just set it to the highest. And definitely,
Getting hot.
it
Do
will
we
consume-
agree with that?
Yes.
Yes or no? we are all making.
But-
I'm not the one. No,
But
I
if
don't know
he, if
anything.
he follows the regulation, if it is nylon, he put it at that nylon position where the energy is going to be very low.
Yeah,
And
yeah.
it will satisfy
So
all
there is
the-
an element of truth in what he's saying,
Yes.
in the sense that if you keep the iron, your cloth needs something, the heat that is a bit lower. So, and you put it on the higher speed, higher heat content. If it is ions that don't have, of course, you
So
burn
there
your
is
clothes.
no iron that doesn't have regulator.
No, some ions don't have.
Yes.
Like when I say regulator, it's on two parts.
Yes.
The thermostat, one.
Yes.
Two, there is this layer at the down part of your iron that can still caution your iron that no, don't go beyond this when you are ironing this clothes.
Yeah.
You get what I'm saying? So in cases like that, so yeah. Can we have another nice one? Nice one, everybody. I like that. So let's have some other
So, excuse me,
contribution.
and let me say something.
Okay.
So it is a common practice in all our homes now. You know, we like to go and open our deep freezer and see that it is all foggy. You see all the ice everywhere. You know, in each and every deep freezer or a freezer or a refrigerator, they also have a thermostat settings. Normally, you see it from 1 to 7. You can conveniently enjoy your refrigerator of a deep freezer when you set it even at maybe between 2 and 3. But you can see in most houses, if you go, you will see it at that 7th mark, which means, no, and that's where I'm going. You understand? When you at number 7, the refrigerator will work 24 hours, 24/7. But if you put it at 3, the deep freezer will work. It will be very cold. All the items inside would block. But after some times, when it reaches a certain time, the thermostat will cut up. And the comparator will consume energy. And it will serve you all the purpose you intended for that.
Okay.
I'm coming. So after some times, when there is need for it to pick up, it will pick up. What we are saying here is that you have set it in such a way that it is going to work efficiently using less energy. But if you put it at that number 7 position, it will continue to work 24 hours. It will be working at the time when you don't even need energy. So in such a situation, you will see that instead of working 24 hours, it will now work for maybe 6 hours in a day, and it will give you the satisfaction you needed from that refrigerator or a deep freezer. Most of the deep freezers are properly lagged. That if they are fully cold, some can stay 24 hours or more. So even if you have a power outage for 24 hours, you are still covered.
Depending on the frequency of how you open.
Eh? That is
Okay.
an abnormal situation.
Okay.
But even at that abnormal situation, we are talking of efficiency here. You understand?
Yes, sir. I really appreciate your
Yes.
contribution.
And also, sir,
We don't want to divide our class. So.
let me say something again.
All right.
Again. If you look at also water heaters, the settings. So in most houses, you will see that they will turn the thermostat to the fullest, which is very bad, even security-wise. So you need to set it. No, because you need to be educated. You understand? So that you put it at a level where if the temperature of the water goes to a certain limit, within acceptable limit, the thermostat will cut off. That thing can stay for maybe 48 hours if you didn't use it with warm water inside. You understand? But if you put it at the highest, you see, maybe after every 5 hours, even if you didn't use it, once the temperature goes below the maximum, it will, the thermostat will on, and the heat will start generating, and you'll be consuming energy. So we are talking of energy, how to efficiently conserve energy, at the same time meeting our demand. Thank you.
Oh, that makes sense.
Yes.
You know, it's a very, talking about energy savings in apartments.
Yes.
So thank you very much for that, sir.
You're welcome, sir.
But basically, the part we are looking at is a question: can bulb be a significant energy uses? Okay, so please, I want us all to contribute to this if possible. But in case we cannot all, the few of us that we are privileged, let's try to make it short and simple so that we can hear a lot of opinion on this. Okay, thank you very much, sir. All right, so once again, do we have one or two people also that want to talk about that? Okay, so I would say when you talk about significant energy uses as bulb, it depends. Some ions are 2,500 watts. If you like, on your bulb, if you have 3 bulbs that are 10 watts, on it for how many hours? Let's check. Let's say 24 hours in a day, right? Huh? Okay, for 16 hours. So, okay. So let's look at the 16 hours. And if we multiply the 60 watts by the 30 watts, thank you. The 30 watts, if you multiply it by the 16, I think we have something like 480, right? And you use your iron for 1 hour. Your bulb will not still measure up.
Are you comparing electric iron with?
As energy uses, yes. In a facility, when you are picking energy uses, you are looking at the whole system. And you want to know which one consumes energy significant. So the reason for this is, I have seen some places where they have light 24 hours.
On the basis of comparison, by mere looking at the rating of an electric bulb and an electric iron, you see most of them, they are not below 1,000 watts, while the electric bulb are just 3 watts for the bulb, for the high energy consumption. So by mere looking at the ratings, you know that this one is higher in terms of
Yes, thank you for that.
You don't need to go to.
But now, this is not what I'm trying to bring out of it. Usually, when you are comparing energy consumption between devices, you don't use a day data.
Yes.
You use a year data.
Yeah.
Now, when you are looking at an ion, maybe sometimes you use it once in a week. Use it for the 1 hour.
Yes.
And the facility, for example, they are poor with their energy management. They put on I have seen some people that they will put on the bulb day and night. You see the bulb. The moment the bulb is off, you can be sure either the bulb is destroyed or there's no power. There's no light.
Sir, recently in modern day time, most of the houses have been equipped with these automatic switches. Once somebody is not there, the switch will automatically switch off the bulbs. Like in the hotels also.
Yes, those
Once
are part
not
of
inside
energy
the room,
saving measures.
everything will go up.
That is energy saving measure that have been introduced
Yes.
when they notice that the bulb is consuming more.
Yes. But we don't. We no more. We no more have a system whereby you leave everything on 24 hours.
We have seen people places like that,
Um,
and I'm talking as an I'm not talking. You see, when we are bringing instances and we are talking about energy saving measures, we are not bringing the best cases alone
Yes.
to tell you that okay, in these places. So if I enter this place now, just coming in and I find all this bulb horn, and they don't have bulb sensors here, this would have been a very good example for me to explain, right?
Yes. Yes.
But if by coming in, bulb have to be on because I come in, I move like this place is off, this one is on. So how do I explain to you about energy savings?
Just
Through the
like
bulb.
just like when we came in here in the morning, we have all the 3 ACs running
Yeah, that's true. That's an example.
constantly.
Yes. So that's a very good example.
Yes.
So thank you very much for that. So, a round all right, so sometimes we can have ICT rooms, and the ICT rooms, of course, we have a lot of devices in the ICT rooms that consumes energy savings. Then you want to come with energy baselines and energy performance indicators, and these ones are to help you know which the performance level of your devices, and it will also help you. So all this will come in your place of your planning. It will come in the place of your planning. Then we want to talk about doing the actions. So sheet where you feeling everything about doing, and what you have, the communication and awareness. Of course, it is good that everybody share the spirit. And one of the ways everybody can share the spirit is you can have like bills, like posts that you put, be energy conscious, switch off after use, and a light of order. So, awareness is very important with energy savings, and, then you talk about the procurement, suggestion box, and a lot of other things that could also come in. So at the check, like I've said earlier, you can actually look at what you have done, because usually in the energy management system tools, you have a goal. You have a goal you want to meet. Let's say, for example, you are starting it by 2025. You are looking at, let's say, 2030, and probably you want to reduce your energy consumption overall by 10% or by 20%. That 10% may mean a big deal depending on your facility, because some facility, just 10% that we talk about can really be calculated into billions and depend on any demand. You can actually talk about that, and then you can always review your processes. Now, this year we have attained 2% reduction. Can we still go ahead further? What are the things that we need to retrofit again? You go ahead, you plan again, that again. You put it in the system. Okay, if I put this amount, if I reduce this consumption, if I add these, okay, so then you can have more structured system. So it's not just like energy audit in the sense that for energy audit, you are not concerned about what happens tomorrow. You are concerned about what happens now. In your facility, this is what you are consuming. I give you the assessment, I give you the spreadsheets. You are not doing well. So try to change on this. If you want to implement, to go to level 3. If you are not implementing that, we'll remain at be aware that you are consuming more. Does that make sense?
Yes.
All right. Next, please. Next. Okay, so case studies. We have instances where we have, like what I told you the other time. We the hall where they have it's a soybean company that we took the shaft, and the shaft, we use it to generate electricity for the company instead of them putting all their resources to get let's say generators that are more, and there's difference between the all these fuel sources and the fossil fuel, because when you are looking at the emission, you are looking at the net emission that you are having. All these husk and everything that you extract, they actually got their CO2 from the environment. When you burn it, it releases the CO2 back to the environment. So you are not really doing a lot to destroying the environment. It's still as it is. So, but unlike the fossil fuel, for example, no, it's throwing everything back to the environment and is increasing what is there. So now, when you are now using all this, number one, it will reduce your money from the cost of production, and also it will help you with the savings, like savings of what you produce, like you not burn so much of fuel that can consume the environment. Okay, next. Then we have the power factor correction, like what I spoke about the other time. If people are aware that poor power factor in your facility will make you pay more, they'll change. And the poor power factor may make you go for bigger capacity that consumes more fuel, that destroys the environment, and also make you spend more. Then just in a year, they were able to pay back by their investment. They implemented it to 18 million naira, and they had 75 million naira back, and able to do that in like 3 months. They pay back. It makes sense. Okay, next. This is British American Tobacco. By implementing a system on their facility, it helped them to be able to reduce their dependence on the grid and fossil fuel. Do you understand? Okay, next. So then 40% reduction from the grid. When there are a lot of analysis also that you can do. Okay, for example, there is this thing where people are they are on band B and they were charged for band A. And over a long time. And the people don't even know, because they don't even know what band they are. So reaching out to us, we understand that the distribution company is actually owing them over, I think that's over 300 million. And when we took it up, of course, it makes savings for them, and it really helped them. So not really like we are anti-power distribution company. We are not. But the essence is so that companies may grow and we can have better productions. Yes, next. Thank you very much for your attention. So I don't know if I should take question and answer now or later. Okay. Do we have questions? Oh, please. Who is with the mic, please? Okay.
Good day, everyone. I've been anticipating for this meeting, and thank God I'm here. My name is Valentine Okoli. I'm into production, food production, and we have a lot of waste. We work basically mainly with cassava. So my question is, like what you showed about that soybean, this thing. Can we have that for our peels in cassava? Because before we used to look at making it into feed for animals, but I see that route. There's not much there. That's coming in. So that's one. Then secondly, if companies want to come together to build this, like having an industrial hub, because truth be told, we may not have the capital to establish this. You get it? But if there are a group of companies around like an industrial hub, can we have, are there facilities that we could approach that would be quote unquote seamless to get such plants installed for that area? Then thirdly, I noticed that Manufacturers Association are one of the organizers here, and I want to specifically talk to them. They are engineers, because they're the ones manufacturing the machines that we use. The machines that we use, in fact, sometimes the wire will hot, sometimes it will. We don't have any form of regulation for them. What I mean is the highest regulation you can have is set it in 1, 2, like maybe a centrifuge. You're using a centrifuge to spin out oil or water. Your hair. All you have is the speed, but nothing concerning the energy efficiency and all that. Sometimes your 1.5 horsepower is consuming something up to, so we can't even measure what we are consuming. So I think their engineers too should be trained on how to produce their machines to also save us cost, and also save cost of production, and also add the prices to these goods when they get to the market.
Okay. May I quickly ask a question there?
Yes.
So the process you just explained now, do you have that variable speed? Is it controlling the electric motor of 1.5 horsepower, or is it controlling, what exactly is it controlling?
The speed is like the motor is controlling the speed. I don't know I don't know much about it. What I mean
Okay.
is, if you put just like your ceiling fan now, if you put it in 1, it's not
Okay.
as fast as when you put it in
Oh, okay, I
5.
get you. I get you. Okay, so in
but
that,
but the thing now is, even if you put it in 1, today your this thing, your wire, your cable is not hot. In that same 1, tomorrow is hot.
okay,
Do you understand?
I
So all
get
we
you.
do is just off and on and use, and so doesn't
Okay,
make
okay,
sense.
okay. So, and 1 is the fastest, right? If I get, okay, the lowest.
1 is the lowest.
Lowest.
Yes.
Okay, so in that, what really happened is that when you're having too much of it on your cable, it's showing that there is more demand on it. And because there is more demand on it, it's drawing more current than what is expected. And that's why it's becoming hot. So at that level, you can probably increase the temperature, the speed rather, a little bit more. If you increase the speed for that operation, because what is happening is that difference in the operation capacity is what is causing that problem.
Yeah, that's true, sir.
So if you can reduce, if you can know when you use this lower operation, use lower speed for that. When you are having a bit higher, use relatively higher, you will address that issue.
Now that makes sense.
Okay, that's number 1. Because the essence of the control that you have there is to actually reduce the speed, which will reduce your energy consumption. If you put it at that higher speed, the higher speed all through, you'll be wasting a lot of energy concerning that. I don't know if you understand what I'm saying.
Yes, I
so
get.
it's basically you understanding the needs that you have at the moment and addressing that. So that's the first one. I think the second question you're talking about, how can companies come together
Yes.
and then make this happen? Like who to meet when the money becomes much? Am I missing 2 things together?
No. You are
Okay.
not. It's
Okay.
just basically to set up these plants.
Okay,
this
great. So
production.
I really want you to understand that one of the goal of workshop is to make you, bring you up to speed in what is presently obtainable. The GEF that we see there, they are in charge of sponsoring. They have a particular fund that they have set aside. This not only GEF, we have a lot of partners that also does that generally. Though there are metrics to that, and I believe we have okay. The project coordinator want to say something concerning that. So, thank you, sir.
There is no crime for industries to come together and access fund. So what he's trying to say is that on this particular project, there is a fund under the Bank of Industry. You can access that fund when it comes to energy management and resource efficient cleaner production. It's a loan under the BOI, but the interest is so small, so you can access that one. You can form cooperative if you are many there using that kind of process. There is nothing bad in that. Then you can access money.
All right, thank you very much, sir. So I believe that is also well addressed. So you have a question?
About man.
Huh?
Man,
About waste. So, like you're having cassava waste to energy kind of a thing. Yes. So now, good. You see, it depends on. Hello, sir? Yes. So it depends on what capacity of waste do you produce, and like how sure are you to be getting it? Now, if you have enough waste, you can always bring electricity out of it. Like you dry it, dry it, it becomes something that can burn. Yeah. Okay. The pews, yeah. 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 Oh, yeah. Okay, now to now get the plant. Okay, that's what you are saying. And it has been addressed, yes. And to now use it as a, yeah, it makes sense. I was thinking you are asking if you can use it. That makes sense. Do we have any other question? Okay. Maybe this is the last question. Oh, we need women to also talk. I will take 2 more questions from after him, so that the time is fast spent. So in case we don't come to you, don't be offended. Sorry, please. We are struggling to hear him.
It's working now. Okay, it's working. Okay, my name is Engineer Morgan, and your lecture has been so interesting. I've listened to your lectures, not just today, and you keep improving. So I want to contribute to. There's a question you asked initially. You made mention of fluctuation in your energy supply to your equipment. At times it goes high, the cable gets hot and everything. So he gave you a solution, because part of what we are doing here is to provide solution to industries. So he gave you a solution. He said if you can monitor when the equipment actually needs you to increase the speed and when you need to lower it. And I said to myself, there's another question that you need to answer by yourself, because some of this efficiency thing we are talking about, it's a whole lot of analysis for you to apply it. If you just run and say, okay, this one is happening, let me go and do this, you might end up creating more problem for yourself. And that simple question is this: do you have skill? No, for the resources you put, your resource inflow, the materials you utilize, do you have skill? Do you use a steady scale? Scale, yes, scale. You weigh it before you put it. So that means you use a steady scale. That means the solution he gave you will not work.
Yes. I'm trying to say.
You get what I mean? It will not work. So he needs maybe an energy expert or a resource efficiency expert to come and look at your process flow to understand where the problem is coming from. But this one, since you're using a steady scale, that means the problem is somewhere else. Yeah. That's why I used scale. So if he's using a steady scale, that means it's a constant thing.
Why RECP is important. The RECP methodology, the 5-step RECP process, challenges to RECP implementation, methodologies for enhancing RECP implementation. I said introduction, resource efficient and cleaner production, RECP. So like I said, you can see why it cannot be less than 1 hour. Usually when we do this, it's a full day, it's a full day's training. But I'll try and see how we can pack as much as possible into the short time we have. And I'll try and make it as simple as possible, because I did not actually know that it was, you people are just getting to know the concept. So I'll not go too much into details, since you're going to have a second training and a third training in future. So let's start with the basics. Next slide, please. The combined IEE RECP approach. The IEE RECP approach can be understood as a systematic, target-driven, and pragmatic process for the facilitation of the exchange of experiences and ideas. Now, all we are trying to say here is that, like I said earlier, you cannot divorce IEE from RECP. You are energy form of resource. Water is a form of resource. The woods are forms of resources, you know. So they are together. So you can, that's why I said the IEE RECP process. It will lead to the implementation of an efficient and effective sustainable energy and environmental management in industries and enterprises in general, and more specifically within a limited group of typically independent enterprises or sites within one region. I saw the young man with the face cap. Where's that young man, the brilliant, fair young man? Has he taken off? But he was talking about the application, you know, that in RECP, there's what we talk about industrial, he mentioned the word industrial hubs, you know, or what we call industrial parks, where we try to, like, if you get to a town like Aba, right now they are trying to do industrial parks, where industries or companies that produce the same kind of things come together, stay in an area, and then facilities are shared. And again, that's where RECP becomes very, very critical. Where we always say in RECP that one man's waste is another man's raw material. So once we understand these basic concepts, that everything is not a waste, and that's what he was talking about. He's into cassava production. They have the husks that they remove from it, which they try to convert to animal feed. That's a raw material for food production, and that's a form of waste minimization. So while IEE deals with the energy issues, RECP does with the environmental management and resource conservation aspects. Next slide. From industrial energy efficiency to resource efficient and cleaner production. IEE focuses primarily on energy optimization in industries, while RECP builds on IEE, but extends the focus to cover all resources, which is all I've been saying all this while. Energy efficiency, reducing energy waste. Water efficiency, minimizing water use and pollution. Material efficiency, reducing raw material waste. Waste and emission reduction, cutting pollution and improving environmental performance. And that's the environmental management issues that we are talking about. Tomorrow, we'll talk about what we call ISO 14000 series, which ISO 14000 is the environmental management systems. He will talk about ISO 50000 series, which is about energy management systems. And these are standards that we use in assessing production facilities. Resource efficient and cleaner production, from cleaner production to zero emissions. I've said it, resource conservation, and then reducing what we call your carbon footprints of your organization. By reducing carbon footprints of your organization, we are talking about carbon dioxide is the basic, but we'll get there, basic tool that we use to measure emissions into the atmosphere. So whether it is methane or sulfur dioxide or nitrous oxides or whatever, we convert them to carbon dioxide equivalents, okay? But we'll get to that later. Next slide. What is RECP about? Resource efficient and cleaner production is a proactive approach that integrates preventive environmental strategies into processes, products, and services to enhance efficiency and reduce risks to humans and the environment. By focusing on the efficient use of materials, water, and energy, RECP aims to improve productivity and competitiveness while minimizing waste and pollution. In more civilized environments, and again we'll get there, you will see this product is made from recycled material. That's part of reducing use of natural resources and reducing emission. So there's a conscious effort globally now to reduce carbon footprints and to conserve materials, including energy. And that's why I said earlier, you cannot divorce IEE from RECP. They go together because it's a form of resource. Next slide. Social enhancement is one of the benefits of performing an RECP properly. Support communities and reduce risks. Its implementation also helps enterprises to do more with less, thus providing more value with less environmental impact and better economic and ecological efficiency. If you look at this place, and production and industry is about human beings first and foremost. It's about the social impact on human beings. It's about the impacts on which is the planet in which we live in. And we are saying, are we going to let suffer? It is globally, climate change is the most important and critical issue facing humanity right now. And everybody is talking about it. We were listening to Trump when he came on board, and he said, drill, baby, drill. So he's going to keep drilling petroleum products. And I agree with him. I'm not saying that what he said is wrong. I mean, if I were the president of Nigeria, I'll definitely drill. Others have drilled and developed from that. But what we're saying is that while doing it, we must at least our impacts. The other aspect, some of it is profit. Organization that is producing wants to make some profit, and they all revolve around the concept of a sustainable system. If we do it all right, then we achieve sustainability. Next slide. Why RECP? Poor industrial practices together with non-consideration of environmental and social impacts of production processes not only impact negatively on the immediate environment, but also contribute to global problems such as climate change, desertification, loss of biodiversity, and pollution of water bodies. Anthropogenic emissions and discharges from industries have become major sources of environmental pollution. When we talk of anthropogenic, don't worry, it's basically these are medical, but anthropogenic simply means caused by human beings, right? By our activities as human beings. RECP is designed to assist industries implement their activities more efficiently by lowering costs through reduced energy, water, and materials usage while minimizing wastes and emissions. So if we reduce, he's talked about how you can reduce your costs through energy, things properly with your energy issues. Using LED bulbs, using more efficient boilers, using more efficient pumps and all that. You can equally do the same thing with water. You can equally do the same thing with materials. Like I said, one man's waste is another man's raw material. People that, the vulcanizers, when you gather tires and all that, there are people that crush tires and then use crumbs and make fresh rubber materials, okay? Even clothing, even food waste, there are people who collect all this waste. I mean, it's fascinating that in a system like ours, where most of our we take to solid waste dumps are biodegradable materials, that we cannot organize ourselves well enough to utilize those biodegradable wastes, which you can use for compost. And we spend so much money importing fertilizers, and it's such a simple process, which you can use to, for production of cooking gas. You know, there are so many processes that you can, but these are the things we're talking about. That one man's waste is another man's raw materials. And that if you think about this, what we call circular economy, you know, that everything becomes a cycle. As you are removing from this, you're turning it and it comes back. It's not just a question of extract from the ground, produce, consume, and then throw away. We are now saying that we must start thinking more holistically, that we can actually, rather than throwing away, we can recycle, we can reuse, we can remake. Okay? What? Yes, we can transform, exactly. These are the critical issues, and that's the heart and soul of RECP. Next slide. global and local challenge, resource, rising costs of raw materials and energy. The whole world, we are talking about resources for, let's take something like paper. I get surprised because we are talking about RECP here, so let me criticize my employers a little bit. Because most of the time, most of us talk about environmental issues, environment, but the amount of paper that we waste but I'm happy that at least, unlike most places that we go, usually they will, for these ones, they will print, no, this is not the one I'm looking for. There's one. At least they were conscious of enough to do front and back. So they've reduced the paper use by 50% already. This is resource conservation. Because to produce 1 ton of, to produce a ream of paper, you might need about a ton of wood, which will cost probably be about 10 trees that you'll be cutting. And the problem is not just about cutting the trees, it's that we don't even replace the trees as we are cutting them. And I come from a state that where every time I go there, I feel like crying because I was a little young man. Most of you, no, I'm sure no other person here was born before the war, the Nigerian Biafra Civil War, but I was born then. So I know how Nigeria looked in the 60s when my parents will take us to go home back to the village for Christmas and all that. All the roads were lined with trees, melina trees. What's this tree that shoots? We call it Okpaka in Igbo, oil bean tree. They lined all the roads from Enugu down to Onitsha, down to my village. But you don't see one single tree in Anambra any longer. We've filled every place with houses, so-called mansions, and of it all is that we have equally done what we call interlocking. Everybody that builds a house now does interlocking, and we do not understand the dangers that we are creating for the environment. But let's face our RECP for now. Resource scarcity, environmental degradation, industrial pollution and climate change impacts, regulatory pressure, stricter compliance on emissions and waste management. The business benefits of REP, it saves costs, lower operational expenses. Let's take something like water. When from your faucet, if water is just dropping, bum, 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 even in our houses, everywhere, you think it's not, because we don't pay for most things here. So people do not actually understand these costs that we are talking about. But when you put, I'm sure we've all had the experience, when you take a bucket of water, and put under a tap that is dropping, bum, 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 by the next morning it's full, right? Even your AC, the water, if you know what I mean. So you can imagine in an industry, several places, there are leaking points all over. And if you're paying for the water, and they are charging you for per cubic liter of water that comes in there, you will then understand the cost implications of what you are doing. Even when you think of the fact that, I have a borehole, so I pump the water, so it comes free, but it does not come because you're going to use a pump. He's just talked about it. And the pump, you're going to use petrol to run it. You're going to maintain the pump. So there are costs to all these things. So saving that, I've just given you one simple example, okay? And then competitive advantage. Sustainable industries attract investments. There's so much global funding. If you do things, the issue is that, like they said, the black man, if you don't want him to know anything, you put it in, what did they say? In a book. Good. So if most of us go online and search, most of us in industries, most of us that are in production, if you go, there's so much global funding for people who want to do things correctly in an environmentally sustainable way. There's global climate fund, there's a global environment facility. There are so many funds but we'll get to that later. We'll see that there are so many opportunities. And that's why I say this is such a critical and important thing that it should be made a national issue, because apart from this, we should train each sector, the media, the finance industry. We've done policy people before, we've done finance, we've done media, but they all need it, because until we all understand important the total concept of resource efficient and cleaner production, we wouldn't understand the amount of losses that we are making. Because the world wants to buy things that are made from sustainable and environmentally sound processes. Then it gives you improved brand image. Eco-friendly businesses gain consumer trust, okay? Maybe not yet here, but it will get here ultimately. Regulatory compliance, avoid fines and legal risks. At least that one is here now, because Nigeria is here, and Nigeria goes around and fines people. But you don't have to get into all that mess. Nigeria does not have to keep chasing you around if you just do the right things. Stop polluting our environment. I keep saying that Nigeria is not even hitting people hard enough, because they keep, oh yes, if you see most of what is happening in our country, what we call industry, the amount of smoke. And people, it's okay, let's use something like the health. I'm a trained medical, I'm a medical doctor, first and foremost, before any other thing. Let's take the health industry, you know, and when you release them here, the most important thing is that when you release them here, they take a very long time to dissipate in the atmosphere. And when we talk about very long time, their half-life usually is over 15, 20 years. And they travel long distances. If you release them here, it cannot impact, just the effect can be felt in somebody in Greenland or something. And probably that's why the whole world got. And so they started asking questions, what's happening, you know, cancers, the environmental impacts of fluorine, chlorine, you know, and then things like PCB. And so the world said, we have to do something about it. These substances have been banned globally. And these are, so that's what the Stockholm Convention is about. The nationally determined contributions is an agreement Nigeria has accepted. After the Paris Conference of the Parties, Nigeria accepted, we are going to do these things to ensure that our impacts on the environment that result in climate change, these are the things. It is voluntary. You have written, and we have developed our own document and signed on to it. This is what we will do. That's what our nationally determined contributions are. And we accepted this. And then we have what we call the National Adaptation Plan, which is what we have agreed that for climate change, these are the things we will do in different sectors of the economy. You have the health sector, which impacts on climate change. There are a lot of activities in the health sector. You have works, you have industry, you have manufacturing, you know, different areas, and that's where it affects RECP. But we will not go too much into details in this. We will do it in higher trainings. We will go in higher trainings, we will go into details into these, and then understand the concepts better. Next slide. And so I'll talk about Kyoto, which I said impacts very, very much on this. There's one other one I did not put there, that Basel Convention, but like I said, when we get to higher levels, we'll go into all those details of all those conventions. The Kyoto Protocol operationalizes the United Nations Framework Convention on Climate Change by committing industrialized countries and economies in transition to limit and reduce greenhouse gases emissions in accordance with agreed individual targets. It is also designed to assist countries in adapting to the adverse effects of climate change and facilitates the development and deployment of technologies that can help increase resilience to the impacts of climate change. One important element of the Kyoto Protocol was the establishment of flexible market mechanisms which are based on the trade of emission permits. Under the protocol, countries must meet their targets primarily through national measures. However, the protocol also offers them an additional means to meet their targets by way of 3 market-based mechanisms. We'll just touch them briefly. With those that graduate to the next class, we will do this in detail. So the 3 market mechanisms, we've said here, countries are expected to manage their environment. It is obligatory. But the world we've been given 3 market-based mechanisms that assist. The first one is what we call the international emissions trading. The second one is what we call clean development mechanisms. And the third one is what we call joint implementation. So I'll just do briefs on this, and then in future. Next slide. So what is the international emissions trading? International emissions trading allows countries that have emission units to spare. To spare. Emissions permitted them but not used to sell this excess capacity to countries that are over their target. Since carbon dioxide is the principal greenhouse gas, people speak simply of trading in carbon. Carbon is now tracked and traded like any other commodity. This is known as the carbon market. Emissions trading schemes may be established as climate policy. So all I'm saying is that, just to understand this, if you don't understand, that carbon, what is carbon dioxide? I said it earlier, that emissions are the emissions that impact on the climate are measured in carbon dioxide equivalent, okay? And so the world has now said, we have set up a market now, and that's why I said there's a huge opportunity for this resource efficient and cleaner production mechanism thing. There's money to be made by the country, there's money to be made by industry, there's money to be made by individuals. There's what we call emissions trading. So the market has been set up. If Nigeria, for example, we have a target that has been given to us that you will not get to this level of carbon emissions, whether it is through methane, whatever, or whatever, but it's all measured under the carbon equivalent. It's converted. Methane is about 32 times more impactful than carbon dioxide. So, but the important thing is that you convert everything to carbon dioxide equivalent. So a market has been set up globally. And if Nigeria, if we are doing so well that we are not emitting up to that quota that has been given, we can get a country like, let's say, Ukraine, that they are producing so much, they are emitting so much, that they can now tell us, okay, since you're not meeting that quota, that you're below that quota, so you're very clean, can we buy some of this by coming to make some investments in your country so that you keep your emissions low, okay? And it's a form of trade, and it is being traded globally right now. So those that are emitting high levels are looking for people that are emitting less so that they can buy their credits from them. Then we have the second instrument. Like I said, these are full topics on their own, so we won't go, we're just scratching the surface. Clean development mechanism provides a standardized emissions offset instrument, allows a country with an emission reduction or emission limitation commitment under the Kyoto Protocol to implement an emission reduction project in developing countries. Such projects can earn sellable certified emission reduction certificates, credits, each equivalent to 1 ton of carbon dioxide, which can be counted towards meeting Kyoto target. A CDM project activity might involve, for example, a rural electrification project using solar panels or the installation of more energy efficient boilers. The mechanism stimulates sustainable development and emissions reductions while giving industrialized countries some flexibility in how they meet their emission reduction or limitation targets. Now, they seem similar, but they are not the same thing, okay? The clean development mechanism is about a country, an industrialized country, which we call Annex B countries, okay, that looks for a developing country, like any country in sub-Saharan Eastern Europe, anywhere. And then they now say that we have this process that we are production. In the course of production, we are emitting so much pollutants. Now, because they cannot reduce theirs, they can now say, I will go to another country and look for a project that I will do that will reduce emissions in that country. Now, let's take, for example, instead of us using coal or petroleum products like diesel, which are pollutants and impact on the climate, they can now say, we will give solar panels to this community, let's say my town, so that we will not take power from the national grid again. Okay? So the amount of power that we now need in the country that comes from renewable sources becomes higher. And those things are now converted into carbon dioxide equivalents, and there's an amount that is fixed for each ton of carbon dioxide. So they can now continue polluting in their own country while they are doing projects in our own country that ensure that we do not. So instead of us to keep burning diesel, using diesel generators and things like that, they will give us solar panels that will give us. That's a very simple, straightforward. So that's clean development mechanisms framework. Then joint implementation, that one does not concern, because it's between two industrialized nations who then decide, okay, this industry you have here, this one you have here, we are going to cut our costs. So I'll jump that. Let's do the next one. Next slide. RECP and CDM, the Clean Development Mechanism is the first and by far the largest carbon offset instrument in the world. To date, it is the only market based on an environmental commodity which managed to attract several billions of euros of private capital on an annual basis. So a lot of companies, that's why I said for RECP, there are so many companies out there. If you set up your business properly, the mechanism, you can actually seek out these companies out there that are looking for ways to cut down on their emissions target. So instead of them, they can now say, okay, you that is producing, your boilers are very inefficient. And so because of it, you're burning so much diesel and you're polluting the environment, putting so much pollutants into the atmosphere. We are going to cut our emissions costs in our own company in Europe by giving you more modern boilers. You understand? They give you much more modern boilers that are much more efficient. So you don't need as much diesel. You cut down your diesel consumption and reduce your pollution into the atmosphere. Okay? So it's a win-win situation. They are cutting their own emissions release, not actually by reducing what they are doing, but by helping you to improve the efficiency of your own production. So those that you are stronger becomes their own. Take credit for it. And there are so many companies. It is there on being done globally right now. The lion's share of the demand comes from the Union emissions trading system, where the Clean Development Mechanism helped companies save millions of euros by reducing emissions where it was the cheapest. That is, they look for companies around the world where they can reduce their emissions targets. The CDM recipe for attracting private investments in the billions of euros per year to climate action is worth some attention and should be looked at by the RECP project in Nigeria. So it's a recommendation that it is very critical and important, and the RECP project in Nigeria looks at this option. Let them train companies, all of us that are participating, that these things are available and can be sought out, and you can get much more modern facilities and equipment, solar power sources, boiler systems, pumps, and the rest of them that are much more efficient from companies that are looking for where to reduce their penalties on emissions. That's why there's a market. If you put CDM market, you will see it. There's a market. There's a global trading market. The way we trade on the stock exchange is the way it is traded now. We trade carbon. Good. But you can call after this. Let's talk. Sure, you know. Okay. I'm a businessman first and foremost. No, but on the serious thing, there's a carbon market, and it is just the way you have stock exchange, global stock exchange. You have a global carbon market, and carbon is being traded the way we trade money. And the difference is that they now use modern technologies for you in place of credit. So credits from them, they pay you for it. Okay. Yeah. It's all about. That's why you're here. But when you go, I'll give you Google clean development mechanism and carbon trading, and then we can take from there. So knowledge is power, and information is power. Good. Next slide. These mechanisms encourage greenhouse gas abatement to start where it is most cost effective, especially in developing countries. That's why the European countries and America, they are targeting, because it's easier here. We haven't started polluting as high. Most of the climate change issues that we are caused by the West, the developed nations, the OECD nations. And it's unfortunate. That's why I've told people there's a book I'm doing on the politics of carbon pollution. And I keep, the book is about, the politics is about, is it right that people developed using petroleum and the rest of them, and then now that we have a chance to develop and catch up, that we are being told you can't use petroleum, which is God-given to us. These are issues we'll have to. And that is why Trump, because he's seen, everybody, self-survival is the first law of nature. If you don't understand that, then you don't understand life. He's come in and said that China is catching up and almost overtaking the US. And all. So are we going to put our hands and then say that we will? No, if it takes, that's why we always say it is only that they carry us and go and keep us in the room and tell us, you can't do this, you can't produce, you can't do this, you can't mine. But when it gets to them, they turn their back, whatever, because they must survive first. But that's politics. But I'm being employed by people. So let me not, before they cancel my contract, let's go. Let's move on. This has the parallel benefits of stimulating green investment in developing countries and including the private sector in the endeavor to cut and hold steady greenhouse gas emissions at a safe level. It also creates the possibility of skipping the use of older, dirtier technology for newer, cleaner infrastructure and systems with obvious longer-term benefits. And of course, it is more economical. Okay? But all that in grammar, this is all we've been saying. You get benefit, newer technology, cleaner, safer. You're not paying for it. Some other person out there pays for it. Comes and takes out your old, decrepit ones, replaces it, and takes the credit for it. Next slide. The inefficient use of natural resources remains a key contributor to climate change. It also leads to growing scarcities. And don't be surprised that I'm talking so much. It's RECP revolves around resource efficiency and then environmental management. And climate change, like I said, is the most critical issue facing humanity as of today. And it will remain this way for at least another 50, 100 years until we can find a way of adapting properly for it. We have all seen, I was just telling, okay, my wife this morning, I don't know if most of you have noticed it, that Harmattan usually used to come around November, December. Am I lying? At least around here, down to the start. Now we are in February, and it's just now that the impact of the Harmattan, you can notice Harmattan is now coming. So there's an obvious change. We've seen that the rainfall patterns have changed very much. Sure, we've seen it. Last year, we saw the flood in Maiduguri. And we saw the number of deaths that were lost. We are not talking about places like my state in Anambra, the number of, if it's a yearly thing, or Bayelsa, or rivers, or, so it is, whether we accept it or not, climate change is real, and it is here, and it is the most critical and essential issue facing humanity right now.